Hello, this is Mr. Briggs coming to you from a holding cell in a small town in northern Alaska. Let me tell you, kids, if a polar bear asks you to watch his house for him, don't do it. That's not his house. But I think I'll teach you a math lesson rather than go into that. Today we're doing lesson 1.3. It's about variability in numerical measurements. The classwork today is on pages 12 through 13 and 3 through 7 and 18 in the ACE problems. Okay, here are our lesson notes that we're going to want to get down. The first one we're going to want to get down is ways of describing variability. Now, variability basically means where the numbers lie, how much they vary, how much they change, and describing them requires some language. The first one is minimum and maximum, and that is the largest and smallest values in a set of data. So, for example, the shortest kid and the tallest kid in class, or the most amount of money and the least amount of money, the lowest temperature this winter, the highest temperature. The range, on the other hand, is the largest value minus the smallest value. Let's say it was -5 this week, and it was also 60 degrees this week. What we would do is we would do 60 minus -5. We would get a range of 65 degrees. That means that our numbers varied 65 degrees between the largest and the smallest. And we can use that to describe our numbers and basically say, well, all our numbers fit between these two values. It's not going to be too large, it's not going to be too small. If we have a very small range, it means our numbers are very closely compacted. If our range is spread out, we know that we got numbers all over the place. And then finally, speaking of numbers all over the place, is an outlier. And an outlier is a value that is set apart from most of the other values. It's something that's standing way out on its own. It's like, where is this crazy number coming from? And my example for that is Mr. Yao Ming. Okay? He is a human outlier. There is no reason why somebody that tall should be that fast. Okay? Moving on. Clusters. When we graph a bunch of data, we get what's called clusters in our data. And basically this means that our data, rather than being spread out, rather than being, let's say, bell-shaped, like we'd expect it to be, where most of the people are lying in the middle, our data falls within one or more big groups. And we see this sometimes, where people are usually this or usually that. They're described as being clusters. And what defines a cluster is having this space between the data. Okay. Your homework for today is lesson 1.3, variability in numerical measurements. It's on 12 through 13, and then you'll do the ACE problems 3 through 7 and 18. Have fun.